Okay, let's just jump right in. What if the materials that build our world weren't so static? What if they were, in a way, alive? We're about to pull back the curtain on a hidden world of objects that can think, react, and change right before our very eyes. Just imagine for a second. What if your coffee mug could actually turn bright red to warn you, hey, I'm too hot? What if the everyday objects all around us could communicate and even warn us of danger before it happens? Well, this isn't some sci-fi movie prop. This is real technology. It's probably in the phone that's in your pocket right now, hiding in plain sight. No, this isn't science fiction at all. This is the very real world of smart materials. And in this explainer, we're going to see how this revolution is already here, actively reshaping the world we live in. So what exactly are they? I mean, think about it. Most materials are passive, right? A block of steel is just a block of steel. But these have a kind of built-in intelligence. They can sense their environment, things like heat, light, or pressure, and then change their properties on command. So the big question is, how? How do they actually do it? Let's get into the science, the nitty-gritty behind these incredible transformations. You've definitely seen some of these in action. Thermochromic materials, they react to heat, and photochromic ones, they react to light. Like those transition lenses in glasses that get dark when you step out into the sun. And this very real problem, just not being able to tell if something's hot by looking at it, it actually inspired a middle school student to come up with a truly brilliant solution using one of these thermochromic materials. What they did was create this amazing coating. Look at that. It dramatically shifts from this bright, safe-looking green to a kind of cautionary brown color right at 45 degrees Celsius. And that's the temperature where you can get a serious scald. It's a simple but incredibly effective visual warning. So what's the magic here? Well, it's all happening at the molecular level. When heat is applied, it literally forces the molecules to twist their physical shape. And that tiny little structural change alters the way light reflects off of them. And poof, the color just changes. It's amazing. But okay, changing color is one thing. That's just the beginning. Some materials can change their entire shape thanks to this incredible property called the shape memory effect. It's basically a two-stage process. When it's hot, it's in what's called the austenite phase. That's its strong parent state, the shape it remembers. Then, when you cool it down, it shifts to the martensite phase, which is really flexible. You can bend it, stretch it. But, and this is the cool part, as soon as you apply heat again, it powerfully snaps right back to that original shape it was programmed with. And this ability to exert a ton of force in a super tiny lightweight package, it makes these shape memory alloys, or SMAs, perfect for all sorts of things. We're talking about the tiny, powerful motors in our smartphone cameras, or even advanced medical implants that can deploy themselves once they're inside the human body. All right, so let's move from the lab and see how these fascinating principles are creating real-world products that are making our world smarter, safer, and even more secure. So next up, we have piezoelectricity. This one is really cool. If you squeeze or press on these materials, they generate an electric charge. And it's a two-way street. Apply electricity to them, and they actually change their shape. So this relationship between force and electricity is the foundation for some incredible stuff. Think artificial muscles for robotics that are super precise, or even devices that can power themselves just by harvesting the energy from vibrations, or even your own footsteps. Now, this is where it gets really creative. Researchers are taking inspiration from nature, like the skin of a chameleon, and from history, like ancient movable type, and they're combining multiple smart properties into a single, highly advanced material. For example, they've made this security film that has 3 different layers of encryption. Check this out. Level 1, a password appears instantly when you shine a UV light on it. Level 2, a totally different password reveals itself slowly, but only to an infrared camera. And for level 3, the physical modules themselves can be rearranged to completely change the code. It's wild. So what's the secret to that time-based infrared password? It's all about thermal conductivity. You can see on this chart, this new composite material they developed conducts heat over 30 times better than the original polymer it's based on. That's what makes that slow, time-delayed reveal even possible. The thing is, these materials aren't just cool new components. They are fundamentally changing how we approach the act of design itself, especially now in the age of the Internet of Things. So instead of the old way, starting with a problem and then trying to find a material that fits, designers are flipping the script. They're starting with the material itself and asking, what new functions, what new experiences can this thing create? It's a whole approach called material-driven design. And why should you care? Why does this matter? Well, the Internet of Things, this massive network of connected devices, is projected to have an absolutely staggering economic impact, somewhere between $4 and $11 trillion. And smart materials, they are one of the key enabling technologies that are unlocking all that potential. I mean, just imagine a future where our bridges, our buildings, even our cars have their own nervous systems. They could use embedded smart materials like these sensors to predict stress, to self-diagnose damage, and literally tell us when they need to be fixed. So really, the big takeaway here is a pretty fundamental shift. We're moving away from just designing with passive, dumb materials, and we're moving toward designing for an active partnership with them. This incredible fusion of physical matter and digital intelligence is just cracking open a world of new possibilities. And it leaves us with a really exciting question to think about. As materials become our active collaborators, what kind of future will we design together?